Guys, you can clearly see that I have a board with me. Its model number of Asus is X415EA R2.0. Today we have it. We will study it in detail and repair it today at advanced level. I will tell you step by step. Please watch the entire video. Everything will become clear. If you skip, if you do, you won't understand anything. So go. I put the charger on and I'm going forward. I'll tell you the processor. So here I found this charger. Look at this. I installed the charger. And over there, if you see, look at this. If you look in the machine, 0.03 is coming. We have 19 volts. All right. So 0.03 is coming, means our charger, which is this, has been connected. Okay, our charger is connected. So now what are we going to do here? First of all, what do we need to check? First, we had to check our 19 volts coming into the board, i.e. the whole place. The supply, it's happening. So that's okay. So our connector is this. If you look at the connector, then our 19 volts is coming. You are seeing in the multimeter 19 volts is coming. Okay, after 19 volts, this is what we have. It is definitely on this side. The connection that is ours. It is definitely here. It is here. It's definitely from here to here to here. Okay, this is the coil. It passed from here to here by coil. It's okay. So here came 19 volts. Now, coil from here. After passing here, take a look. A register is provided. Here you are looking. Yes, I will take the coil closer here. After that, there is also a register. See this? There is also a register. Okay, there is also a register. Then we'll let it go. The register is going somewhere else. Let me tell you. Then look here after the coil. We have our 19 on this side. Volt is coming. Alright, we have a total of 19 volts flowing from this point to the other side, maintaining our 19 volts. Observe, the voltage is absent. What's going on here? 19 volts. This marks the beginning of the mosaic. Proceeding forward from this point is supplied. So from here to yours, in the board, there will be a complete absence of supply. So please explain how your board will function. Observe, the voltage is not reaching this point. So what exactly is the Mosfet? It's a gate here. Take a closer look. A gate. There is a gate where it gets the signal here, due to which the supply of our board is ahead. If it's ahead here, see most of them here. Here, if I am keeping it at the gate, then see here voltage, nothing is coming. This is the big reason. I will tell you further. Why isn't he coming? That's it. First, I will take out this charger. After removing it, I'll explain further. Alright, here's what I'll share. What exactly do people like that do with their time? So, if they will hit a jumper from here, what do people do to this Mosfet? Take it out from here and hit a jumper here, install wire direct, and then supply it to the entire board. Goes. This approach to safeguarding our motherboard is absolutely incorrect. He's totally out. Goes. That's his life. Whatever comes inside gets shot. So directly our board gets damaged, then we have to change the board. So today we will repair the JSCO. In a very professional way. The video will become very long. It will become too long, but if you watch the whole, you will understand in full detail. Every board has this system that I am telling you. This is the board. The system is in every board. So complete this video. See the full. You step by step I will tell you in full detail in advanced level. Alright, let's head over here now. Nonetheless, I maintain it in diode mode. Observe this diode mode I have set. Firstly, we need to verify whether it is an N-channel or P-channel Mosfet. So I positioned the red probe here. Note that this one indicates it is an N-channel Mosfet. Alright. The component we are dealing with is an N-channel Mosfet. And if you manage to repair it, you will subsequently obtain both N-channel and P-channel Mosfets. So it's basic. You know that. It shall now be operational. Here we are. The N-channel. In order to facilitate voltage transfer through the N-channel, higher voltage at the N-channel compared to the input is essential. So that I will show you in more detail and understand you in detail. See how much input is coming to us. We have input coming in. 19 volts. Okay. Hold 20 volts. Hold 19 volts. Round figure 19 volts is coming. Okay. 19 volts is coming. So what is on this gate? What is on this gate? What is on this gate? And the gate of the channel should have more voltage than 19 volts. Then this is yours from here to here. will pass. But here the condition is such that there is no voltage here, so obviously the voltage will not pass. So let me tell you the next step. So see here, our 1 voltage will go from here to here, then from here. The second mouse that will go to wait will go to register with the second mouse. So what's the first thing to do? The register will continue to be checked. Here I show the snake. The register has to be checked first. Does this case happen in this? Or sometimes the voltage does not pass due to shooting in the board, as I told you before. For protection, the Mosfet is installed so that the voltage does not shorten anywhere in the future, but it blocks it here. Then here this condition is like this. I show you. See, I have put it in diode mode, and in the register here, look here, 00 is not coming. It is coming around 400. Okay? So this OMS shows us that there is no further shooting in the board. Okay, look at both sides. It is the same. Then even after there is no further shooting in the board, the voltage is not passing, then here we have a problem. You are in the solution. Professionals, I'll tell you how. The schematic of why the board comes on is not available. If its schematic is not available, then why do we have a board for it? So why will that board study this board today? So let's come to PC and look over here like I was looking over here. See here, what is our connector? Okay, this is our connector. Now where is this connector from? See here, what is our connector? DC jack is showing in the boarding. Okay, this is our DC jack. Voltage of DC jack plus point. Where it's coming? So as I told you, it is coming to the coil. So see, this is coming on the coil. Where is it going from the coil to the other side? And from the other side, where is it going now? Here I flip the boat from the other side. See this flipped after flipping? See here, you are coming here. Where are you coming on? This first one is coming on the first one. So you need voltage at the first gate. You need voltage at the gate here. Now there will be no voltage at the gate. Then it will increase further. Otherwise, let us find such a gate. Then you will not find the gate. First of all, I will show you one thing. The connection of such a gate, which is our charging is done through IC. Then here we have charging IC. Then most of the boards have BQIC, which is for charging. So I have already searched here. See this? I have done everything for you first for the study. See this? What is our BQ? Do you see? BQ24780S. Okay, then let's go to the board and see this from the back that came to the board. This is ours. Okay, that is the same. Now how will they identify this? Now there are a lot of pins, so you don't keep collecting more of them. This is not to check the entire pin. I'll tell you what to check. Okay, so first come to its pin number 1. It's pin number 1. Well, let's not get into it. What do we have to see first? Well, first we have to see and then we have to see. Power okay, AC okay. This is seeing AC okay. Okay, so what are we going to see first? VCC, VCC, you will know VCC means voltage, which is the voltage of ICOH. First of all, if you want voltage, then they check VCC. What is its pin number? 28. Then we will check its VC on pin number 28. So let me extract it in pin number 28, Vano pin number 28, then see it is already showing here. So pin number 28 is the last pin. Its pin number is 28. This is so from here we check SIR diode mode, see our voltage, which is pin number 28 from here went to spin directly. I don't know why it can be short, but I still see it. Gives it once. It is a sign of danger. Look, the voltage is coming on this. Look, I have installed it and look at the voltage there.
Voltage is coming. Okay, what is ours is VCC. The IC is getting it. Charging IC. Yes, charging IC is getting VCC. What else will we check now? Acid detect is fine. Most of the problems of these two things in every charging IC are acid detect and VCC. Both are more problematic. And then after that, AC is okay too. Then I will tell you later. Whenever a problem arises, let's check first. Now what is the second acid? Now look here. What is ours? Voltage is not coming here. Okay, then even before the voltage comes, a voltage is passing from here. A direct from here also gets to this IC. Before here, this IC gets it. Then you see the voltage at the gate. AC detect. This is what you are seeing in this. Acid detect is seen by the same name. Acid detect, AC detect means AC has been detected. The IC should know this. So its AC detect should come. What is the AC detect on? The pin number is on 6, isn't it visible? Pin number 6, 1, 2, 3, 4, 5, 6. Pin number 6 now, which is of pin number 6 connected to it. Okay, as much as yellow is showing, pin number 6 connected to it. You will check the pin number here, touch it, and maybe you will get a shot. If you find it on the second pin, then how much is 123.4444 for this register? Then see 123 for here. There is a capacitor, sir. This is the voltage here. See, our voltage is not coming here. Okay. Now the voltage is not coming here. So how will such a person know, brother? Acid has been detected. Is it not acid? Detect now from here. Such a connection is also provided here. We will click on it once. And if here we click on the register, then look here. Spin on one side. Look on the other side. This is showing AC details, and here this is the other side. Here what is showing here is the ground, right? So if you want to check the village a little, then leave this too. And now come to this register. What is this register showing, right? And what is this showing? Pre-charging is fine. And what does this show? Ducking means charger. In OK, charger detect. Duck and pin short. AC, look here, look here. I will show you. Look from here. This pin is this connect. This is 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 connect. And this is the checkpoint. So many things which are connected with this pin is okay. So what will we do? Click on direct and after clicking on this, we will click on this. Then we will come to this and see here. We will check on this. These two registers are going somewhere else. We will check on this here. Then this deduction, where is it ours? This pen is fine. See, let's see how much upside down it is coming here. 1.3 is coming. If you will see 1.3 and 1.3 voltage has started coming, which was not coming now a little bit. Meaning there is a problem here in AC detect. Let me first tell you how much voltage I need. In AC detect from 2.2 to 2.3.0, the voltage stays in any range. It stays different in every board. Mostly I saw 2.7 volts. Well, 2.7 volt in is normal, which is perfect. So here now see how much is coming here. We are coming up with 1.3, which is much less than 2.2, right? So what do we do now? It will look at the register. This register is getting 0.3 of this register. So what's next? How much is coming this way? 19 volts. 19 volts are coming and coming down this side, right? 19 volts coming this way. It is coming down to 0.3 points. See, if the voltage starts decreasing, then what will we do with it now? We will change this register. Now how much is this register? How many ohms is this register? This register is from 01.27 of 127. So what are we going to do with 127? I take out the register. If they put it again from the register book, then I take it out first. So guys, I'm taking it out. Look at this, friends. I have taken out a register. Now I put it. It is the same register. Okay, now I put this register in its place there. If I have changed it, then it's voltage which was not passing. Then when it is not passing, then the voltage will not know this detail. Well, friends, after seeing, I have changed this, okay? The register which was ours here, I have changed that register because the voltage which we did not have. So here I click, I do one click, sorry, I will charge. I have charged, now look there. Our laptop has turned on automatically. Look at the MP which started taking by itself, meaning our voltage must have passed. Look at our voltage, which is 19, has passed all. Look here, 24 volts has come more volts than the input, and here I will show you the voltage on this capacitor is coming 2.6 on this capacitor. What I told you, 2.2 to 2.2 to 3 volts. This should be in between. See, this our 2.6 is coming, and I will tell you why 2.6 is coming. The voltage divider in this right there is the voltage divider. I will tell later. We can increase the voltage from the voltage 222 register. Alright, I'll tell you more about it in the next video. Right now, I have told you what its voltage is, how we will pass it, and which pin we have to check in the charging IC. I have told you all this. Only then has this board been turned on by us. What is our laptop? It's on. Well, our voltage which has passed. You can see here. Our voltage which is starting to pass over here. Look, the voltage came here too. Voltage has come here too. And look in the board there too. Our amperage has started coming okay. Okay, then we are going to have such an informative video of mine. You can also give me advice on how to make the video and make it in a good way. How to make. Thank you so much for watching the video and subscribe to my channel. Thank you very much for watching such an informative video.